Hello, fifth graders. This is Mrs. Ellis from Martin City, and today we are going to be talking about three-dimensional solids, specifically prisms and pyramids. We're going to compare and contrast them on a couple of different ways. We're going to talk about their number of edges, faces, and vertices, and we're also going to talk about the types of bases. Hello, fabulous fifth graders. Welcome to Miss Ellis's house, and I'd like you to meet my two helpers, Emily
Hi.
and Lizzie.
Hello.
And today we are going to be learning about prisms and pyramids. Dun, dun, dun. First, let's take a look at prisms. This is a slide from your independent practice today, but it's also a little bit like notes because we're going to be filling in some of this together. We're going to start with prisms, and here are some things that are true about all prisms. Prisms are named by the shape of their base. They have two congruent bases. Congruent is a math word that means exactly the same shape, exactly the same size. And they have rectangular side faces. Let's take a look at a prism and see if we can understand these properties a little bit better. So let's take a look at our very first prism. Lizzie here has a triangular prism. And it is called a triangular prism because the shape of its base is a triangle. There's a triangle here, and then back facing Lizzie is another triangle. Let's go ahead and see this prism in action. Let's take a look at the properties of this prism. Now, three-dimensional solids, polyhedron, have faces, which are these flat sides here. And so this is a face. They also have edges. This is an edge where two faces come together. And they also have vertices. A vertex is where edges come together and make a point. And the plural of vertex is vertices. So let's learn about the properties of Lizzie's prism. Let's start with talking about edges. I can tell that this shape has 1, 2, 3, 4, 5, and there's an edge we can't really see here, 6, and then there's that congruent triangle in the back, 7, 8, and 9. Lizzie's prism has 9 edges. What about faces? Well, there's a special face right here. This is the base, but is also one of the faces. And we know there's a congruent base in the back, so that's 1 and 2. And then there's also 3, 4, and 5. There are 5 faces to Lizzie's shape. Finally, vertices. Vertices here, here, and here. And then also here, here, and a little guy here we can't see. There are 6 vertices. So we discovered that our triangular prism has 9 edges, 5 faces, and 6 vertices. Let's see what else we have in store. Now let's take a look at some pyramids and see if we can figure out what sort of things are the same and what sort of things are different between prisms and pyramids. So here's your pyramid note slide. Let's learn about what all pyramids have in common. All pyramids are named by the shape of their base. They have one base, and their side faces are triangular. And all of their sides meet up to a top vertex, which has a special name called the apex. Let's take a look at a triangular pyramid and see what we can learn. Let's have a look at Emily's triangular pyramid. You can see that its side faces are triangles. It only has one base. Its base is this triangle here down at the bottom. And opposite of its base, everything comes up to the very top to a very special vertex called the apex. So let's go ahead and find out about the properties of Emily's triangular pyramid. First, we'll start with edges. There's an edge here, here, and in the back. And then there's an edge on each side, here, here, and here, of the base. So there are 6 edges. What about faces? Well, we know that a triangular pyramid has a triangular base. So here is one face, it's a triangle. Then we have 2, 3, and 4. There are 4 faces. And for vertices, we have one on the corner, each corner of our base. And then we have one more vertex up here, that special one called the apex. So altogether, Emily's triangular pyramid has 4 vertices. So let's go ahead and work on our notes here. Please pay close attention that you're filling this in on your pyramids slide. So we just looked at Emily's triangular pyramid, and we saw that it had 6 edges. It had 4 faces, and it had 4 vertices. Let's see what we can find out by looking at some other prisms and pyramids. Here, Emily has a rectangular prism. We should be pretty familiar with rectangular prisms because we spent last week finding the volume of a right rectangular prism using length, width, and height. So you can see that all of the side faces are rectangles, and it has 2 congruent bases. Okay, so let's start by looking at the edges. Here, Emily's rectangular prism has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then this guy we can't see makes 12. There are 12 edges. How about the faces? Well, it has a base. It has 2 congruent bases. So 1, 2, then 3, 4, 5, and 6. There are 6 faces. And finally, let's talk about the vertices. I see 1, 2, 3, 4, 5, 6, down here makes 7, and this little hidden guy makes 8. There are 8 vertices. Now, just like we learned last week that a square is a special type of rectangle, there's also a special type of rectangular prism called a cube. A cube you should be pretty familiar with, but it has all of the sides are perfect squares. But it is still a rectangular prism, and it still has 12 edges. It has 6 faces, just like a die, and 8 vertices. Let's go back and add that to our notes about prisms. Make sure you're on your prism page and not your pyramid page. A square prism, a rectangular prism, that is having 12 edges, 6 faces, and 8 vertices. Let's take a look and see what we could find out about Lizzie's square pyramid here. As you can see, again, we have triangular side faces. And down on the bottom, we have our base. There's only one base, and that base is a square. That gives our pyramid its name, a square pyramid. Now let's check out these properties. Let's talk about edges. We know that since the base is a square, there is an edge here, 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 and here. That's 4 edges. Also here, 5, 6, 7, and in the back where we can't see, 8. There are 8 edges. Let's look at the faces next. The base is a special face. It is a square and gives it its name. So here's 1, then there's 2, 3, 4, and 5. There are 5 faces. And finally, let's check out those vertices. We know that there's a vertex on each corner of our base. So there's 1, 2, 3, 4, and again, one more for our apex. There are 5 vertices. Let's go ahead and add that to our notes, making sure we're on our pyramids page. A square or rectangular pyramid will always have 8 edges, 5 faces, and 5 vertices. We're going to explore prisms and pyramids with one more base shape. Emily here has a hexagonal prism. It's a hexagonal prism because it has 2 congruent hexagon bases. But you'll notice on the sides that connect them, those are all squares or rectangles. So let's see if we can look at the properties of this hexagonal prism. Again, let's start with our edges. So we have a hexagon here. 1, 2, 3, 4, 5, 6. There's a hexagon on the bottom too. 1, 2, 3, 4, 5, 6. So that makes 12. Then there's also 13, 14, 15, 16, 17, and 18. There are 18 edges in a hexagonal prism. What about faces? Well, because it's a prism, it has 1, 2 hexagon faces that are its base, and then there are 3, 4, 5, 6, 7, 8 total faces. 8 faces. Finally, let's talk about the vertices. Remember, vertices are where several edges come together to form a point. So there's 1, 2, 3, 4, 5, 6 around the top base, 7, 8, 9, 10, 11, and 12. 12 vertices in a hexagonal prism. Let's go ahead and add what we've discovered to our prism notes. Please make sure that you're on the prisms page. Our hexagonal prism had 18 edges. It had 8 faces, and it had 12 vertices. On your own, down here, I want you to just tell me about one pattern or connection you can make about prisms and their edges, faces, and vertices. The last three-dimensional solid we're going to look at today is a hexagonal pyramid. Let's look at the properties of pyramids when they have a hexagon as a base. So here is Lizzie's hexagonal pyramid. Again, you can see that there are triangular side faces. You can see that they go up to the top and make an apex. And that down here on the bottom, there is a base that is the shape of a hexagon. She's nervous about breaking it. So, let's go ahead and look at our properties. Let's start with the edges. Again, we know that there is a hexagon on the bottom. So we have 1, 2, 3, 4, 5, 6 along the base. Then 7, 8, 9, 10, 11, and 12. 12 edges on our hexagonal pyramid. Now let's take a look at the faces. We know that there is a hexagon down here on the bottom, so our base makes one face, and then there is 2, 3, 4, 5, 6, and 7. There are 7 faces in a hexagonal pyramid. Finally, let's have a look at the vertices. There are 1, 2, 3, 4, 5, 6 vertices along our base, and then our very special vertex up at the top called the apex for 7 vertices. Let's go ahead and finish up our notes. Make sure you're on the pyramid page. In our hexagonal pyramid, we had 12 edges. We had 7 faces, and we had 7 vertices. I'd like you to look here and write about one pattern or connection that you see when you're looking at pyramids and their properties. Finally, for the last bit of independent work, I'd like you to compare and contrast what we've learned about prisms and pyramids. Over here, write 2 things that are true only about prisms. Over here, write two things that are only true about pyramids. And here, you're going to write two things that are true about both. All right, fifth graders, thank you so much for learning with me today. Today we compared and contrasted properties of prisms and pyramids. The properties we looked at were edges, faces, vertices, and their types of base.